Hey everybody! Before we left, we were talking about fractions. Think back to the lesson of the tangram, the square, that we cut into all the little pieces, the triangles, the parallelograms, the little square. And then we talked about that each piece of that tangram was a fraction of the whole. A fraction is a smaller piece of the whole. So today we're going to look at some unit fractions. Here I have a triangle, and remember, Miss Kent, I didn't get a ruler out and measure this, so it's not going to be precise, but I did the best I could freehand. Here I have a triangle. There are two equal parts. Now, are they 100% equal? No, I didn't get a ruler, but the best that I could do to make this equal freehanded, this would be equal. Number of shaded parts. So I have one shaded part. Now here's where the unit comes in. Units here, we have 2. That means that this represents 1/2. 1/2. When we cut something in 2 pieces, we call those pieces halves. Or this is 1/2, 1/2, or you have 2 halves. Fraction form would be 1/2. You do not say 1 out of 2. If you start talking about 1 out of 2, you're talking about having 2 objects. 1 out of 2. Okay? Here we're talking about a fraction of something. A fraction of 1 whole. Now some people like to write 1/2. Some people like to write it like that. Both ways are correct. Let's look at this next one. This next one reminds me of something we've used in class before when adding, subtracting, multiplying. That's called a tape diagram. Remember when we used that? Here this tape diagram has 3 equal parts. One of those parts are shaded in. What would this unit form, what could we name this one part? Because there's 3 pieces, we would call it 1/3. 1/3. We would write that fraction like that, 1/3. Not 1 of 3, because that would mean you had 3 individual pieces and one of them was shaded in. Here we have one piece with one hole with one piece shaded in. Here's a square. It's supposed to be a square. It kind of looks like a rectangle. How many pieces do we have? 4. How many of those pieces are shaded in? 1. Now we have 1/2, 1/3. This would be called 1/4. Now I always have to make sure that I spell that right because that's one of those that tricks me up. Oh, you know what? It is F-O-U. You know when I spell 40, that's where it always tricks me because when you write 40, you write, wait, hold on. Or is it 14? Oh, now I'm going to have to look it up. I forget which one I get confused on. Is it 40 or 14? I don't know. Let me see. Is it 40? Yeah, it's 40 because when you write the word 40, it's F-O-R-T-Y. But when we write fourth, it is F-O-U-R. Oh, wait. Look at me. I just can't even get this together. F-O-U-R-T-H, fourth. Not fourthy. Not fourthy. And this fraction would be written 1/4. Not 1 out of 4. Because we have one whole. There's 4 pieces and one of those is shaded. Now let's look at this next one. This one's kind of different. Are those pieces equal? They are equal, or as close to I could draw them as equal free-handed. There's 1, 2, 3, 4, 5, 6 pieces. How many are shaded? What would I call this? If this is a half, a third, a fourth, 1/6. So my fraction would be 1/6. So when we say these fractions, we don't say 1, 2. No, that's a half. We don't say 1/3. That is 1/3, or people say a third. The letter A, would represent 1. 1/4, or a fourth. 1/6, or a sixth. Okay? And you're going to see some other fractions that are not talking about 1 in the future. But when you see that bottom number, you know it's a third, fourth, or sixth. Now, I want to go over a word problem kind of quickly to show you how we've already been talking about fractions in class, and you just didn't really know it as we were going over it. Hold on just a second. More word problem up. Okay. So, Miss Brown, I'm sure Miss Brown is having a nice break right now at home. I'm sure she's still working to try to get reading stuff together. She cut a 10-meter rope into 2 jump ropes. So here's what Miss Brown did today. She had a 10-meter rope, just a long rope, and she wanted to make 2 shorter jump ropes. What could my question be here? What would I need to know? Now, if I think about it, and I know Miss Brown has a 10-meter rope, would Miss Brown want to cut it into a piece of 2 meters and 8 meters? Would that be okay? So like maybe she has a kindergartner with short legs that could use that 2-meter rope. And then maybe there's a 5th grader that can use that 8-meter rope. I don't think that would be right, because what if the 2-meter one was just way too short? Then she just wasted some of the rope. Oh. So I think the question might be, if she cut the rope into equal parts. Hey, here's that word, equal parts. When we're talking about fraction, we're talking about equal parts. If she cut the rope into equal parts, how long would each part be? Now, this is a fairly simple problem because we've used it when talking about division and multiplication. However, this time we're thinking about fractions, equal parts. I want you to stop the video now and just on a piece of scratch paper or maybe on anything you have at home. It doesn't have to be a piece of notebook paper. If you carried your toolbox home with you, you could get one of the pages in there. Remember, don't tear it out because all the pages will fall out. Just write on it. I want you to stop the video now, and I want you to solve this problem, drawing a picture that would represent the fractional equal parts of the rope. So stop the video now, draw a picture that could represent the equal parts of the rope. Okay, so when I think about my rope, I'm going to go back to my rope is 10 meters long. And I just went ahead and drew a picture of a rope, okay? Now Miss Brown wants to cut it into 2 equal parts. Because she's making 2 jump ropes. So here if I cut it into 2 equal parts, I'd probably cut it right about there, okay? I'm going to draw a tape diagram because they have always been so helpful for me. Now I have 2 equal parts here. So I need to divide that 10 meters into 2 equal parts. If this part were 6 meters, this part would have to be 6 meters. Cora and Jack, stop yelling. Six and 6 makes 12. It doesn't make 10, so that can't be right. What about 5 and 5? Oh, 5 and 5 does make 10. So if she had a rope that was 5 meters and 5 meters, would that be equal? It would. Stop the video now and I want you to write an equation. An equation. There's several equations you could have written. If you decided to add, you could have said 5 meters plus 5 meters equals 10 meters. You could even subtract 10 meters minus 5 meters equals 5 meters. What about multiplying? If I had 2 ropes that were 5 meters long, together they'd be 10 meters. Or you could even divide 10 meters divided into 2 groups. Each group would have 5 meters, okay? So we've been working with these fractions all along with these tape diagrams when we've been talking about equal parts with multiplication, because that's all a fraction is an equal part of a shape. I hope this is going to help you with your work. We're going to continue to have a few lessons about fractions so that you can understand equivalent fractions. Have a good day.